All right, so the second part of 3.1, and what we're getting into, is solving multi-step equations, but particularly for this one, 2 steps. So meaning, when I go through all of these steps, this is how we're going to solve. These are the rules that we're going to use for all of our equations when we're solving for something. So simplify each side of the equation, clear the equation of fractions and decimals. We just do fractions. We can deal with decimals, especially since we're using calculators so much. You might want to clear the fractions to make things easier. You may have to distribute, which we've done in previous sections, combining like terms, another thing we've also done. And then after we do that, we add or subtract to isolate constants, which are terms without variables on one side of the equation, and variables on the other side so that they're opposite of the equal sign of each other. And then we multiply or divide to get the positive variable by itself, which is kind of what we did yesterday. So because this is we are taking kind of like baby steps to get to where we need to be, we're going to focus on 2-step equations, meaning we're going to use 2 of these steps with 3 and 2. Essentially, we're working backwards. All right, so we're going to start with step 2 and then do step 3. Typically, especially if we have a multi-step problem, our last thing that we do is going to be to multiply or divide to get the positive variable by itself. So that's 9 times out of 10 is going to be your last step or the last thing you do. You might be adding and subtracting terms a lot before you get to that step 3. So let's see what we are talking about when we are talking about 2-step equations of how we're going to solve for a variable. So 2-step just means exactly that. It should take us 2 levels of inverse operations to be able to solve for a problem. So I have 3 examples here. Now in this first example, again, the first thing I always want to do is identify where the variable term is, especially if there's only one. So if we see here, that y is our ultimate goal, right? We want to get that y by itself. We want to make that 2 become a 1. If we can get that on its own side of the equation, then that's where we want to be. So similar to the previous section with just a single step, my goal right now is to get the 2y by itself and then to get the y by itself. So I have 2 terms on this side. I have a 2y and a -3. So I want to get rid of that -3. We're going to use the inverse operation of addition, so I'm going to add the opposite. So I'm going to add 3 to that to make it 0. Now remember, the same rule applies. Whatever I do on one side of the equation, I have to do on the other side of the equation. So I'm going to add 3 to that 7. I'm bringing down my equal sign right in the middle. That's 0. Those are gone. I have a 2y on this side. 7 plus 3 gives me 10. Again, use your calculators, guys, to help you out. So now that I've done that first step, I have the variable term and a constant on opposite sides. This is what I mean by that. You get constants on one side, a variable term on the other side. So now I'm here, I get to do my last step. I have to now mathematically make this a 1. So I can't subtract 2 to make it a 0, because that does not fall under our like terms rules, right? 2y and a -2 are not like terms, so we can't combine them mathematically. So, but we can do is multiply or divide them. So I am going to divide this by 2, this whole thing. 2 divided by 2 is 1. That leaves us with the y by itself. All right, I divide this side by 2 because whatever I do on this side, I have to do on the other side. 10 divided by 2 gives us 5. So 5 is our answer. Now again, we're not going to check this, and I'm not going to check all of these, but I'm going to show you how it works. We talked about substitution. If y equals 5, 2 times y minus 3, and then I put in the 5. And if I type that into my calculator, then I should get the answer. So I'm bringing up my calculator here, so I didn't have that ready to go. Oops. So if I type this in, and we talked about substitution earlier, so 2 parentheses 5 minus 3, and you see that it comes out as 7. Yay, 7. So we know we did it right. So let's go ahead and go through our other examples based on our 2 steps. So again, we identify our variable term. In this case, our variable term is x over 9. The other term on this side is our negative 15. All right, so we want to get rid of that negative 15. We are going to add 15. So we're going to add 15 to this side as well. Those are like terms because they're both constants. So I'm going to bring down my equal sign. On this side, I have x over 9. And then I have negative 15 plus 15, which is 0. And then 12 plus 15, which would be 27. All right, over here, remember our rule, if we multiply by the denominator, we get the numerator by itself. So over here, what I'm going to want to do, and I always, again, we're using inverse operations, always think of the opposite. This was 2 times y, we divided. Here's x divided by 9, opposite of division, it's multiplication. So I'm going to multiply by 9, both sides. So whatever you do on one side, you have to do the exact same thing on the opposite side. These will then divide out, giving me x by itself over here. And then I would do 9 times 27 to get my answer. So 9 times 27 is 243. So again, if I put that into my original problem, 243 divided by 9 minus 15. That should give us 12. Let's go ahead and just have fun. We got some time. If you're bored with that, you get it. You can fast forward this anyway. All right, so let's see if that comes out to equal, should come out to equal what? Should come out to equal 12 if I did it right. So 243 over 9. I'm going to hit my arrow to the right. I'm going to subtract 15. And I get 12. Boom. All right. So I'm on the right track. We know we're getting it right. We are undoing these to get to what makes these things true. All right, over here I have 2 terms as well. I have a negative x and I have a positive 15. All right, so I am going to get rid of that 15. I want to get this x by itself first, so subtract 15 from both sides. So that's going to be 0, so I have negative x equals, and then 12 minus 15, when we do that in our calculator, will give us negative 3. Now from here, we need to make this a positive. We can see this right now as a negative 1. All right, there's 2 ways we can go about making this positive. We can either divide it by a negative 1, which equals positive 1, or we can multiply it by negative 1, which gives us positive 1. Whenever I see a multiplication problem like this, so if I think of it as this, I just divide it by negative 1. That's my personal preference. I think it's easier to draw out rather than put the parentheses. So anytime you see a negative variable, just divide it by a negative and you'll get a positive. So if I go back to this, divided by negative 1, that's going to give me a positive x. So then I have to divide this by negative 1. And that will give me a positive 3. And of course, if you are not sure about that, continue to trust your calculator. So if we did negative 3 divided by negative 1, that gives us a positive 3 over here.